day we use satellite images. If you are slightly into computers and using Google Map for looking at the place. So when I want to come to this place, I started looking at Goris, Madina Center Google Map. Every day when I travel to different places, I keep using Google for this. So one of the best use of image processing or application straight away is using Google. Though the topic talks about image processing and its applications. After seeing the schedule, I thought I will only talk about image processing applications, image processing and remote. And it is remote, so only applications. Images, many people say that you may look at images only satellite image or maybe normal photographs. The methodology keeps changing. It could be an X-ray image, or it could be a reflection, or it could be a transmission, or a projector onto the screen. The photograph keeps shifting based on the camera, film and processing, and the X-ray vision and film, television, camera, TV, etc. When you look at images, what we see is using our spectral band, which is in visible range. I am sure madam is going to cover the basics. In which 0.4 micrometer to 0.4 micrometer is visible range, white light. Images need not be in that. You can use special filters for getting temperature maps. We have a center here called INCOIS, International Center for Ocean Information Services. They use only temperature map to find out where fish is available in the sea. They are the people who are supposed to give information to all fishermen across the country to say where you have to go and fetch fish. Because fish understands the boundary between temperature differences and there they will go and settle. And our satellite from the top will see where the fish is and then the fisherman will go and catch. So you can imagine the applications of image processing, applications of satellite image in which field, which is not acceptable. I said whatever information which you get is also applicable to medical imaging. So ultrasound scanning, which is an old technology which is used for many purposes. One information you must know that because we are not using visible range, most of the pictures will look entirely different for you. If you don't know which filter you are using. For example, you are seeing a blue color, you use a blue glass, it will look entirely different. If you use a red glass, it looks entirely different. So it depends on the wavelength which you use as a filter, you will see image entirely different. So you can see some of the images which looks entirely different in gamma ray, X-ray, this is same image. Okay, visible region, you can see it looks entirely different. Infrared and radio waves. So based on what glass I am using, for what application I am using, I can create my own image for my purposes. So images can be categorized based on the source in which you are doing. My specialization happened to be in stereo image processing for defense applications. So you show me an image, I will tell you what sort of flight is there, which aircraft, which manufacturer, from which company it makes, and which country is using it, and what should be the counter for us. Okay, and you have a lot of applications in environment, you have applications in meteorology, you have applications in laboratories, you have applications in painting, infrared. We have got some specific images which is used by killing photography where you can find ghosts. Okay, your aura can be pictured and see whether you are alive or dead. The picture can tell you. I remember when I was traveling to China, there was somebody who is supposed to put your stamp visa for entry. He takes a picture and says, yeah, you can go in. He asked, what is that you are doing? You are taking the picture to find out whether you have fever or not. You don't have to come closer. You can take picture and find out the temperature and say this person has fever or not. Okay? So that's image processing applications. You can see the fingerprinting. If tomorrow there is a theft here, the police will come and take our fingerprint. 3-4 places it will happen. One during the marriage registration, land registration, and during theft. See, be careful. So the fingerprint analysis is one problem. I remember when I joined the Department of Space, our CMC was giving training on fingerprint analysis. I got a special training on fingerprint analysis during that time. So far the problem is not solved. So it's approximately 25 years back people started solving this problem. You can't solve it because the fingerprint is very unique. It works for me, it may not work for somebody else. And forgery is something which, medical images is something which keep on changing. Photography, printing, desktop publishing, as image processing, there are a lot of imaging change. Processing earlier used to be chemical. I happened to be the head of the department of photo lab in my office. We had an art photo lab. The image processing is chemistry for us. Mixing chemistry in barrels and then processing it like old small studios you will see where the images are processed. We have large photograph in which kilometers of length photographs can be printed. So that's our facility which we have. It used to be electrical and digital. So if you ask image processing, it's a chemistry subject, it's a physics subject, it's an electrical subject, it's an electronic subject, it's a geography, people will say it's my subject. So it's like we have in Kerala curry called avil. All the vegetables can be put inside and then makes it. That is image processing. If you tell this is, yes. If somebody else tells this is my field, yes, it's your field. So anybody can get into this. Now doctors are getting into it. This is one pixel. I remember when I went to Austria for selecting a pixel scanner for defense. It is 0.4 micrometer. Maybe your hair can be cut into 30 pieces. What you will see is what that is what you should see and select. Oh, this is the scanner. And this scanner can scan images which will disclose everything what is inside the film. I remember when he asked me, are you able to see? I said, yes, I can see that. He said, yeah, what are you, ma'am? Which you can see a hair which is cut into 30 pieces. Drishti naam gojra. What you can see this? Jnani naam drishti gojra. If you have knowledge, you can see that. That is what is image processing. You may not see it with your eye, but you can understand with your sense what does it look like and how does it look like. That is because image processing will not show you the pixel resolution which is the width of the road, but a continuous road will tell you there is a road. That is image interpretation, image analysis. That's what his specialization is. Looking at the image, you must be able to interpret and then say what is it. That's another big field where you can work. If you don't know the image chain, you may not be able to analyze it. This is one CCD element which you have. You can see how much is the length. If you have only 6 centimeter, that is what is on top of the satellite at 600 kilometer, and it will see every drainage pipe whether it is leaking or not. You can understand that is the process which we have, because 0.4 micrometer is what is getting 10 meter on the ground to that resolution when I started working, and today it's 0.5 meter resolution. That means small details. If some small boy is sucking some rubber, you can see that whether what sort of rubber is that. Okay? That's the resolution which people can see. Resolution is the details in which you can see that. The visible light length, in which we have got the wavelength, different wavelength. The only visible region is what we are looking at it. Infrared, ultraviolet, X-ray are also used for different imaging applications. Gamma rays are used. Electromagnetic spectrum have got different wavelength. This one is the resolution 1 kilometer to 1 meter. I am sure there is a special lecture on satellite imaging, so I am skipping this. Long wavelength you can have. Image will look entirely different. It is the same structure, but based on which camera you are using, which spectrum you are using, it will see entirely different. One is infrared, another one is visible. It is not snow, it is a creeper, vegetation which is on the wall. That is what you are seeing as snow. Okay? So if you don't know analysis, you will misinterpret the whole thing. The wavelength matters. This India is a bloody India, full of blood. Red color, it doesn't mean it is full of blood, it is vegetation. Green is what is shown as red. And this is called the false color composite. The color is not the natural color, it is the false color composite, the image. This is what the soil map. Green, then you can see this is the sea zone where you have got red. It doesn't mean the sea is full of blood. The temperature is what is shown as red, and the low temperature is what is shown as yellow, and very low temperature is what is shown as black. So in between is the place where the fish will sit. These are applications of image processing. Now today we have green, and we know green from, if a paddy field is watered, we know how much green it is. If it is not watered, it will become yellowish green. So looking at the leaf, you will say it is not watered. Satellite can be used for this purpose. So you don't have to go to the field, use the satellite, take the picture, analyze it, say, and scold the labor who is meant for what. That's possible. So these are the applications. These geological applications, you can see different colors represents different minerals available under the earth, not on the earth, below the earth. Okay? So that's possible. I am not showing these images. You have range images, sonic images, and this is one image where you have got a tag which is not very clear. You can use what is called filters. I am sure Madam is going to explain the fundamentals, and what I am trying to say is not identifying the image, that's a recognition part, and analysis part is naming them, which tag is used by whom. During war, most of the people will fool people by putting some dummy there. It may not work, but you make a dummy and keep it there and then fool others. That's done in war. I happen to be in defense intelligence work, training defense people was my job. So we do a lot of such exercise to show them what can be done, what cannot be done. We can see building from the satellite to count how many floors are there, because we can count the number of windows to say that how many floors are there. That's the resolution with which we work now. We can generate 3D from the relief. Shadows will show you whether it is 3-dimensional or not. There is one application, geological application. This is my first 3-dimensional image which I generated, so I can show everyone. I generated the Chandigarh perspective. So Chandigarh city from the ground, there is a hill. From 2 satellite images you can generate this. This is possible. I can only show you this. Whatever I have generated cannot be shown because most of them are defense related outside country. If I show that, the people will ask me. So that applications are very crucial for defense purposes. The civilian applications are only mixed to show what we do in the real defense applications. We can use surface modeling to make the building structure available. I remember working on Pentagon when the palm portion was born. We have to recreate that Pentagon, how does it look like? That was also generated. We can have, all these are generated from satellite image taken from 600 to 800 kilometer height in a stereo, not one camera, 2 cameras on different days. So this is one of the application, visualization. What are the purpose for this? You can do an analysis of surface model to find out when there is a flood, how much will go into water, so that you can safeguard the area. If there is a flood, how much area will go underwater? This is one of the applications which are natural resources, how to control them. The building topology, you will see all these building topologies are used for defense purposes. Same thing they will copy and use it for games. You are more familiar in games. When the car drives, where does it go, where it hits and all that. You understand image processing, spend maximum money in gaming. If you want to be an image processing man, the best field is get into that, you will enjoy doing games. And for which you will be paid large amount. Okay? So there is a lot of scope. You need to have good imagination and also a fun of making nice field. I saw one of the girl who is from Kerala, only one girl from Asia, one girl from India, and the only one girl who is from Kerala who is working in Hollywood for making video animations. Most of the movies what you see are all generated by her team. It's a wonderful field where you can make a lot of animations. This is Pentagon, the damage is being seen. And traffic monitoring is one application where it can be directly seen. You can do a recognition of the traffic. Now you can see if some police wanted to track one vehicle, the police need not be there. Whole traffic is imaged. So you can track them and then get them, catch them and fire. Very easy. Okay? India you cannot fire them, you can bribe properly. These are one of the applications which you have. And you have traffic monitoring. One of the policing job is to detect the face. You have got similarly like a vehicle, you can also detect the face. Major problem in face detection, if you take my picture and if I shave and come, you will recognize me. Is it possible to train the machines to do such a job? And what features have to be used to recognize a face? These are some questions which are generally asked. So geometry is what is used for detecting the faces. And archived like this, which are scan and character recognition. Biometrics used for security purposes. You can see the biometric image of the finger, which is used for biometry and for the eye. The fingerprint analysis I already told you. The age, you can guess this man is this in 1990, in 2012, how he will be. Understand, this is why I said image processing is an unending problem. Because you project this man will look like this, but really he doesn't look like this. He looks like this. So now you know how image processing fails. More failures in image processing than success. Therefore, very good. You can have a lot of research. And everybody can write PhD thesis, and you get your award and say I'm an image processing man. Failure, more. Success will come later. Okay? And fractals is what? The illumination in the outside. Deep blurring. One of the major projects which we did in our office was where is that man? Yeah, Rajiv Gandhi's assassination. Rajiv Gandhi was assassinated, the image was available, we wanted to know who killed him. And therefore the image was given by all the photographers. We have to deep blur it. And deep blur and identify this is the person, this is the lady with the camera who killed him. Okay? See, that was one of the deep blurring application that was my first assignment in my team. So we have, the image becomes very clear. This is one of the major problems which we have. The traffic will take a picture of your vehicle, and if you are driving very fast, will you be able to get the registration number? That's image processing application. Okay? Motion blurring. Many applications on this. And you can fool. Somebody said image is what is convincing and showing. Most of the time it is not truth. You have hidden information inside image. Bin Laden used to send a lot of photograph like this, but you process it, you will get a message. Go and assemble at this place on this day. So images are used for giving messages, hidden messages. Okay? Facial expression recognition, it's another field. Face tracking. Activity, this is done in the border areas. We don't have to always stand looking at whether somebody is crossing the border or not. We can keep a camera. If somebody is crossing, the camera will start tilting accordingly wherever he is moving. This is what is motion recognition. You can do it on security applications. Morphing is another area. You can insert object and then fool people. This is what I said. Vision is inferral. Vision is geometry. So if you know geometry, you know what is it. Looking at this, you know whether it is a depth or bubble up. You are confused. Whatever you think is not right. You just think the reverse, it will become reverse for you. Because I am showing the next image. It is the same, I am putting it the reverse time. This image and the other image is entirely different, right? Now whether it is up or down. In one image you will see it up, another image you will see it down, because the direction in which you look matters. So you can imagine whether image is fooling you or not. So images can fool people. Be very careful, okay? And visualization panorama is one application where you can do this. There is a lot of applications in civil engineering. If somebody says I am civil engineering, I don't have anything to do in image processing, you are wrong. A lot of applications in civil engineering and image processing. After my retirement, I was working with one of the construction company who construct palaces abroad. Okay? So we do a lot of simulation and show them this is how your palace will look after this. Oh, then construct it. So you need to show him the image row by row, place by place before construction. There are a lot of applications of image processing in civil engineering. Computer vision, yes. Taxonomy, different structures. I am not describing this. This is what happens inside. Real-time problems, visualization. What are the real-time visualization problems? Look at it. This is one example where the number of flights landing in one airport is being mapped. Each line shows one flight traveling. So you want to know the density of air travel. Which area is less utilized for traveling. There is only way of visualizing this. So every line which the flight travels is put into an image form to look at the density. Recently I saw some analysis of showing the date of birth for the entry of academics. We found that the people in Tamil Nadu, most of them will take birth in May. You know the reason? Because during the admission, you have to put 5 years, so they will manipulate the date of birth. And we found that most of the people have date of birth the 5th, 10th, 12th, and 15th and 25th only. 12th and 13th there is no. Because you write number, automatically there is a genuineness in you. If you are genuine, you will write the right number. If you are not genuine, you will write 5 multiples. So that is what happened. So you can catch the thief using image processing. You cannot visualize it in numbers, but you put them as figures and the diagrams, you will be able to visualize it. So color coding is one way of understanding real time problems. The display in future, yeah, I remember meeting the Nokia vice president once, and he asked me, he wants a few people in image processing to work with them. I was guiding some of the students in MTech in image processing in Kerala University. I sent the list of students. All the students said we already got employment much better than in Nokia company. If you do an MTech in image processing, job is guaranteed. Not like not attending the classes and manipulating your thesis. Do a real effort. Then you will get job. Okay? Because the problem is you have got a normal fault. Just one question is enough. You do research, the companies will buy you. All the displays are rectangle or square, yes or no? Can you make a cylindrical or oval shaped display so that your telephone will become in this shape and you can hold it and keep it? It is not coming just because display is the restriction. You cannot have a display in round shape. Otherwise my laptop would have been an oval shape earlier, right? So the future of image processing is going to be, you will have a laptop like this. As a watch, as a ring, okay? As a bangle. And image processing has a lot of applications. This is going to be the future of display. You will not have display at all. You will have only projector. I think Apple is coming with a laptop in which you don't require audio, you don't require a display. You can just project it wherever you want. So you can just lie down and then see the screen there on the top and then work on the computer. The display becomes the roof. That's possible. So you have got a lot of possibility of, and probably a day will come that the image processing chip will be inside your brain so that you will detect people. You will not have no problem in identifying your mother. Right? Because the image of the mother is inside, you know, oh, this is my mother, yes. The computer says this is my mother. So image processing will have real-time applications in robotics and people will become robots. Okay, boundary detection. You can see there is something there, right? Squirrel. Yeah, you are able to find out, but the computer will not be able to find out. Now what we do a segmentation, and just the segmentation will tell you because the temperature is different for the tree and the squirrel. So temperature is used as a color code for identifying. Only the temperature difference is enough. You understand now the applications of temperature map, right? It's a wonderful area where you have got boundary detection to medical. The texture is created. You will see a lot of variants now today with a lot of, no, I am a fool, written by somebody, right? That's because of place printers. And tracking in the sports, tracking in games, tracking in the motion, tracking in the roads, and medical tracking, face shading, identifying people, forensic is policing. I happen to be in police for some time. So there's a job which we do. Get people and get them. And yes, you can fool people by shadows. NASA fooled everybody with images. Nobody landed. And this is my son who is standing in the center with a glass. Actually, he was taking photograph. And how you can be inside? Normal Adobe is enough. You know how to fool, right? But how you can catch him? He said, don't fool people because his leg is missing. Okay? Only face is there. So when you fool, you must know how to fool properly, 100%. Otherwise, intelligence fellow will catch you. There are lot of celebrities pictures are there. This is a fooling people because the shadow of the leg is one side, the shadow of the face is on the other side. So if you are a police, you can catch images and say that this is taken one season and another one. Is it real? No. You look at the shadows, you will catch it. This is taken on a day and the other one is taken on 2005 and 2004. Two images mixed together. So don't believe images. Don't believe people. They have a different face. That's why when you are in love, you will say, you are very good. After marriage, you will say, I will show you a real face. That means you know how to hide the face, right? And that is marriage. Yeah. This is possible. Just one image processing is enough to find out whether it's a gimmick, whether the person is real or not. That's image processing techniques. Right? I will show you two pictures and you can take and mix them together to make a bigger picture because your camera has limitations. You cannot go behind it to take the large picture. Now what do? Take in pieces and connect them. And you should have a seamless mosaic. These two pictures are mosaiced together to make a seamless. That's what is called image panorama. You can see one example here. Take another 10 minutes. Yeah, you can see a lot of bits and pieces are taken. And you will see when the patch them together, you will see a gap because it is different illumination, different conditions. And what is the problem here? You must connect them such a way that it doesn't look like pieces. It must be continuous. You will see how it is done. Just mathematics. And if you want to do PhD, 2-3 people can do PhD under this, and still the problem will remain. Because for one image you solve it, for another image it will not work. Because shadow is different, shape is different, place is different, features are different, camera is different, keeps on changing. So that's a patch. Now the sky looks like sky. It is not the real one. If you take a large picture, it will not be like this. But nobody can take it because you have something else behind, so you cannot go and then take pictures. These are all done through mathematics. Okay? So if you want to be image processing, you must know. In multimedia, e-learning, now today you cannot show the inside of the heart. If no doctor can open it up to show to the doctors how a heart looks like, right? It's all simulations. So if you are a good computer person, get a medical person beside and ask him all the information, you make simulations. It's very well used in education purpose and multimedia. I happen to be part of UGC, CEC, Consortium for Educational Communication, where we generate multimedia lectures. You can see, this is a class on DNA pattern.
Almost all of our cells, the muscle cells that let us smile, the brain cells.
And what you have screen all over. And therefore you get a 3D film. We are sitting inside the bus. You will see close to you the animal jumping across you. So it gives a real film. This is not done for a joke. This is what is used in training people in military. Because you cannot train people taking them to a terrorist place to train them. You need training before really going into the place, right? So military training, animated simulators are very, very essential. This is one of the major applications. What you will see in tourism, what you will see in games are only a fallout of what is happening in the defense field. That is why people spend a lot of money in image processing in defense areas. Right? Yeah, you have gloves, you have head. The military simulation I am not showing because any games which you see will be like a military one, where people are trained how to fire, how the people will die, all that is possible. There are simulators, there are medical simulators available today. The doctors need not do the surgery. Doctor will sit somewhere and the younger doctor will start pulling it up and then doing the surgery with the guidance from the people. This is the advantage of better resolution images. So you can get all the details. The surgery is done by keyhole. The camera goes inside. Most of the time the endoscopy, the 3D, the tumor size, you are not opening it to see. Only camera goes inside. What goes inside the bite is camera. And what you see is a three-dimensional picture of that. Most of the applications are now in the liver. The liver surgery, you have to cut the liver, take two pieces, put it into two people. And the space what is created for putting this liver has to be exactly matching with what you cut from the other person. Otherwise mismatch will be the space will not be enough. So how much to cut? You have to volume has to be measured before cutting. You understood? So you cannot do it after cutting, take the weight and find out whether the weight is correct or not. You can't do that. So all these are done through simulations. You go and search on internet, liver image processing. There is a fantastic liver image processing. Subject itself. So image processing has reached up to liver level. Okay? It has reached from brain to liver. Studio movies. You have got 3D models created. You can see them in 3 dimensions. You can see Bollywood is using it. And you can see some magazines used to come with a glass. This is the glass which is used. You have one image with one color, another image with another color, and then use this, and then look at it, the animal will come. The three-dimensional feeling will come. That's what it is. Okay? Yeah. This is Mars. The Mars in 3D. As if you are landing there and then walking, you can see that. And you have got virtual right now. You don't have to spend money and traveling and going into a park. You just wear the glass and then enjoy the ride. You will see as if you are going. You are not attracted with the stage. You will feel that it is there. You will feel that you are driving and then moving inside the vehicle. Check your heart. If you have buddhi only, you will see. So So, any research like image processing is also like problem will start solving, eating you, but you should eat the problem. That is what is research. This is what is research. When you get into research, the problem will eat. You want to play again? Before research, the problem is very big and you will get scared. But if you once you get into that, you can solve the problem, and problem is very less. Okay? So enjoy learning, that's my message. For today, I think I took half an hour. And your feedbacks should come on my email. Then you become my student. Get into internet, there are 61 blogs which I run. 61 blogs. Okay? And there are a lot of learning which happens. I'm happy that Global Institute is assuring that we will have some association for training people on IAS. We have got students, I have got Anusha and Sweta, few of my students who are into IAS and IPS. You will see them as IPS officers in 2 years. And we have got one IAS officer coming. They are from GIET. Anusha, stand up. She passed out from GIET in 2004. This is how I said, she is JV Moments Engineering. She is from there. She is aspiring for becoming IPS. You will see my class during the holidays at my house. Whatever happens will be there on Facebook. I have a community called Civil Aspirants Group. If any one of you would like to start image processing group, you could start. We'll post all the image processing applications and learning from that. Let this be a spark and let somebody funny stand up. Yeah, he wants to do research in image processing. Give him a big clap. One month back he was on chat with me asking what can be done in image processing. Now you know what cannot be done in image processing. That's it. So this is a message which I have. I'm sure by end of evening you will be much more knowledgeable than me. Thank you. God bless you. Thanks a lot.